So not my best video, but hopefully going to help you understand exponential functions since you'll be taking your National Spanish exam. And we're going to be able to identify and graph these exponential functions that we see tonight. So we're going to recognize an exponential function when we have an x as an exponent in our function. So let's take a look at that. So I've got f of x equals a times b to the raised to the x power. So I need to make sure that a is not equal to 0, and b cannot be equal to 1, and b is greater than 0. Those are my constraints, and you'll want to write all that down. So I've got this function, f of x equals 2 times the quantity 4 raised to the x, and that models a flea population after x days. So I want to know what the population will be on the third day. So my x represents the number of days, and I've asked for the third day what the population is going to be. So I've got f of x, and that number is going to be 3, equals 2 times the quantity 4 raised to the third power. And I'm just going to use my calculator and calculate 2 times 4 to the third, which is 128. So after 3 days, I will have 128 fleas. I've got another exponential function here, and it's about money. So I've got a certificate of deposit which I'm going to hold on to for a certain number of years. So my x in this case is going to be the number of years that I have my CD. This function, f of x equals 500 times 1.035 raised to the x, says that I have a CD that I am purchasing for $500. This is the principal amount that I'm investing in the CD. I've got an interest rate here of 3.5%. So as I raise this is essentially compound interest. Over the period 6 years, how much will my $500 be worth if it earns compound interest at 3.5% annually? So we're going to, again, put this in our calculator as 500 times 1.035 raised to the, in the first case, 6 years. So if I put this in my calculator, I see that after 6 years, my account, my CD, is now worth $614.63. Please make sure you're pulling out your calculator and trying this so you're getting the same number. I would recommend that you use your parentheses so that you're raising just this number to the 6th power. After 10 years, how much is my CD worth? Well, again, plugging in for this equation, now I'm going to change this to an exponent of 10. My CD is now worth $705.30. So we're seeing the benefit of compound interest. So what I want to know is this set of ordered pairs an exponential function? Well, we talked yesterday about geometric sequences, and what we saw was a common ratio. So I'm going to see if there is a common ratio in order to determine if this is an exponential function. So again, I'm going to look at my second term, divide it by the term previous. So 1 divided by 0.25 is 4. And I'm going to just check to make sure that these other terms match this as well. 4 divided by 1 is also 4, and 16 divided by 4 is also 4. So I do have a common ratio of 4. To have in your notes, linear functions. If we remember back several months ago, I'm going to have a common first difference. That's what determines a linear function. Remember, with a quadratic function, I've got a constant second difference. Exponential function, I'm not looking for a constant difference, but I do need to have a constant ratio. So pause your video for a moment and check to see if this set of ordered pairs satisfies an exponential function. So in fact, I have an exponential function because I have a constant ratio of 3. How about here? Pause your video again for a sec. Here my ratio is -1, 2, and 3. I do not have a constant ratio, therefore this is not an exponential function. So now we're going to take a look at what a graph of an exponential function looks like. So we're going to set up an XY table to come up with some values to graph. I'm going to use this example, 3 times 2 to the x power, and I'm just going to set up my normal XY table of -2, -1, 0, 1, and 2. And I'm going to come up with these values, and please go ahead and make sure you're coming up with the same values that I come up with. But -2, my y will be 0.75, -1, 1.5, 0 will give me 3, 1, 6, and 2, 12. All I'm doing is plugging in for this x value. Okay, just to make sure that you know what I'm asking you to do, I'm asking you to find the value 3 times the quantity 2 raised to the, and instead of x, I'm going to put in this value, -2. And when I hit enter, you'll see that 3 times 2 raised to the -2 gives me 0.75. And again, as long as I'm using my parentheses, I will get the correct numbers. So you'll continue that. I've got 3 times 2 raised to the quantity -1. And that's where I got my value of 1.5, etc. Okay, so I'm going to graph these points. I've got -2, 0.75. I've got -1, 1.5, 0, 3, 1, 6, 2, 12. And what you're going to see is this is going to graph, from my beautiful graph, a curved line that is going to go up infinitely, but as it comes to the left, it's going to approach the x-axis and it will actually never touch it. Okay, so notice when we had a positive value for B, a positive value for B, and a positive A, we saw a exponential function graph going up to the right. So now I want to take a look at a situation where I've got an A that is less than 0. So here I've got a -3 for my A. So again, I'm going to set up my XY table, use your calculator again to come up with your values, and my table will look like this. Not surprisingly, these numbers are just the negative value that we just saw a minute ago, because we haven't changed anything about this except made our A negative instead of positive. So again, I'm going to graph these. -2, -0.75, -1, -1.5, 0, -3, 1, -6, and 2, -12. So what I see is my curve, oh, beautifully drawn, is a reflection across the x-axis of what we just graphed a minute ago. Okay? All right, so now remember my B has to be a number that is not 1, but it has to be positive. That was way back. We've only seen bases that are greater than 1. But I want to take a look at a base that is less than 1, but it still, remember, must be positive. Okay? So I've got an A of 2. My B is now 0.5. So let's take a look at what I'm going to get for values and what this graph will look like. So I've got -2, -1, 0, 1, 2. I've got the values 8, 4, 2, 1, and 0.5. You can plug these into your calculator and check to make sure these look okay. Negative 2, 8, negative 1, 4, 0, 2, 1, 1, and 2.5. And what you'll see is, again, a graph where it's approaching the x-axis. It will actually never touch, unlike mine, and it will go infinitely high in this other direction. Okay? And I've got one more scenario, of course. I've got a negative a value and a b, again, that is less than 1. So let's look and see. I've got x, y, negative 2, negative 1, 0, 1, 2. My y values will be negative 16, negative 4, negative 1, negative 0.25, negative 0.625. Okay, and I'm going to graph that. Negative 2, negative 16 is even off my graph here. Negative 1, negative 4, 0, negative 1, 1, negative 0.25, 2. Actually, that's a 0. My apologies. Okay, so again, this should never touch the x-axis, but it will get awfully close, and it's going way extremely down. So, summing that all up, if I have an a value that is greater than 0, I'm going to go in the positive direction. This is with a b that is also greater than 1. Over here, I've got a b that is less than 1, but again, I've got the a greater than 0 or an a less than 0. So they're going to be reflected over each other. All right, so here we're going to do a application problem, exponential functions. We actually are going to see these in the real world. So in the year 2000, the population of a city was about 5,000. It was growing by 1.05% each year. So I want to know at this growth rate, if I can map that with this function, f of x equals 5 times, here's that percent increase, what the population will be in thousands after X number of years. So in fact, when will that population reach 6,000? So I need you to go ahead and write down this function because I want to know the function f of x equals 5 times this quantity when that x, what that x will be in order to reach or exceed 6,000. So I'm going to have to clear here so I can get my calculator up again. I'm going to plug in that exact function. I've got 5 times the quantity, 1.0105, and I'm going to raise it, use your caret, to the x. This is the same x that we always use for our equations. And then I'm going to hit enter, and I'm going to go into my table. So you'll notice in year 0, I've got 5,000, and I'm just going to keep skimming down my table until I have exceeded 6,000. And look there at year 18, it looks like I have exceeded 6,000. So in fact, in 18 years, I will have reached and exceeded a population of 6,000. All right. Here are your video questions. Please go ahead and write these down on paper that you can turn in to me since I won't see you during class. Quick joke for you. Asks his dad, "Dad, I'm going to a party tonight. Can you do my math homework for me?" Dad says, "I'm sorry, son, it just wouldn't be right." Son says, "That's okay. Can you give it a try anyway?" Good luck on your Spanish. I will see you all tomorrow.